Hey, what's up? This is Madan sir, and I'm back with another, very important topic. That's going to be, I would say one hell of a topic from the aldehyde ketones in carboxylic, and this hell of a topic is called iodoform test. So I'm saying, this is a hell because this is really very important, and what I see, the way I like, it's something going to be very interesting right now. So let me introduce to you this iodoform test. Involves actually finding the methyl ketone present in a organic compound. So we basically, when we try to do this iodoform test, we try to find out the methyl ketone in a organic compound, right? So the main topic is called oxidation of methyl ketone. But while you do this research, while you do this detection, you come across making iodoform, which is a yellow color compound, right? So that's why it is popularly named iodoform test. So let me introduce to you and see what there are, because trust me, this is really going to be very important. The previous two topic, tollen, fehling, and this is the third one in sequence, very important for any sort of exam. Doesn't matter if it's cbse exam or you have your NEET exam or whatever. So let me just give me a second, please. Okay, so what basically I'm talking is about oxidation of methyl ketone. So this is what the topic mainly is, but this is also called, like I said, also called haloform test, haloform reaction, I should say, haloform reaction, and then this is also called iodoform test, right? So this is where everything moves around. What I have in my mind is to make you understand what this methyl ketone is. So you have to understand what this methyl ketone is. A methyl ketone is something like R, C, double bond O, and a CH3. You need to remember that this part is called methyl ketone. This part is called methyl ketone. So what happened in the reaction, this methyl ketone is detected, right? So this is your methyl ketone. Now very important thing is that you have alpha carbon. Remember, there is alpha carbon here also, but this is also alpha carbon. So what that means, this carbon has 3 alpha hydrogen also. Alpha hydrogen, right? And along with the carbon. So you have 3 alpha hydrogen. What are the characteristics of alpha hydrogen? That is very important. And alpha hydrogen is highly acidic. So these are highly acidic, right? So you have went through what are alpha hydrogen, what is methyl ketone. Now let's go further and see what this reaction is involved. The second important thing about this topic is that in this reaction, what happened actually, that this methyl group when react with halogen molecule and NaOH, an alkaline solution. So it actually require 3 moles of halogen here. So it require, you have to understand that this one is needed 3 moles, and this one has to be 4 mole. How they are going to be used, I'm coming to the mechanism part, then I will let you know how this is. So what that mean, all the hydrogen from this methyl, they are substituted by the halogen. So this becomes CHX3. This becomes CHX3. Now this is called haloform. right? And this particular, you can call it whatever group you say, but it has a carbonyl. This react with the sodium. This react with the sodium. So this sodium react with, remaining other part, and it forms a salt RC double bond ONA. So this is a salt here. This is a salt. So this is the overall reaction. This is the overall reaction. Now, due to the formation of CHX3, this is called haloform. But, if you use, halogen X2, this X2 can be chlorine. If it's chlorine, you will be forming CHCl3. In that case, it is called chloroform. It is called chloroform. However, if this is, if X is bromine, you will get CHBr3, and this will form bromoform. And similarly, if your X is iodine, this will be forming CHI3, and this one is called iodoform. Now, the question is, why this is only called iodoform? Because these two are colorless. But this one is yellow. This one is a yellow compound, right? So because while you perform this test, and if you are using chlorine and bromine, you won't be getting any color. So you hardly will be in a situation to find out what happened inside the test, right? But when you use, iodine in place of X, you will be able to see the change in color in the form of yellow, and that is how iodine is responsible for making this test feasible for you, because you will be able to see the change. So the only iodine will be able to make the change, and you can see that. So that's why this entire test is popularly called iodoform test. So the first thing, are you sure, how I have made clear why this test is called iodoform very popularly? Because you can use any, halogen. You can use chlorine, you can use bromine, you can use iodine. But in case of chlorine, bromine, you won't be getting any color. So you won't be able to see what changes you have, done over there. But if you use the iodine, you will see the change in color yellow. So due to that yellow color formation, you will be able to see the change. So that's why it's called the iodoform test, right? Okay. Now let me take you through the remaining part. So we have to go through the mechanism part, right? Now let's talk about the mechanism of the haloform reaction, where you will be able to solve so many questions from different exams, right? So the mechanism is going to be interesting, and though it's not something you have to do it for your CBSE, but for competitive exam it is very, very important. So I have mechanism, the very next topic here. So in the mechanism of the reaction, I will start with the original compound with the methyl ketone. So what happened? This one react with the sodium hydroxide. Like I said earlier, this reaction takes place under basic medium. Now you do know that the hydrogen here on the carbon, is highly acidic. This is a alpha hydrogen, and alpha hydrogens are very acidic. And they are highly acidic. So what happened? The hydroxide ion produced by NaOH, is attracted towards itself. Now this result formation of H2O. And then you form a carbon ion, because this bond breaks in such a manner that you form a carb anion. So you have CH2, with a negative charge. Right? Now this product again react with the halogen molecule. But there is a problem. This is a non-polar molecule. Right? So it will not react on its own. But what happened? This one, being highly polar, induced a dipole here. So this become partial positive and this become partial negative. And due to that, the halogen moved towards the carbon. And after that, it is able to form that first hydrogen removed, R, C, double bond, O, you have CH2 2 and X. So the very first halogen have been removed here. Now let's make this process go ahead. In the next step, what happened? You have to use 2 mole of NaOH and 2 mole of halogen. Why? Because like we saw that in order to remove one hydrogen, we needed one NaOH, right, and one halogen. Therefore, in order to remove 2 hydrogen, we need 2 NaOH and 2 halogen molecule, and therefore we will be able to form R, C, double bond O, and you have CX3 here. Now, what happened? That's very important here. If you see that there are halogen molecule here, so only one of the halogen atom is utilized. So what happened to the rest of the halogen? What happened to the remaining halogen? Those remaining halogen combine with Na to form NaX. So you form 2 NaX over there, right? In the next step, what happened? This reaction undergo further, and this takes place in presence of OH. Now you probably know that OH is highly basic, right? OH is highly basic. Now this is a plus sign, not something you have to confuse. Now you do know that the oxygen is partial negative and this carbon is partial positive. So this hydroxide actually shift towards the carbon, right? But in order to do so, this bond has to be broken. This bond has to be broken. So due to the bond is broken, what happened? OH attach itself to the carbon, but CX3 come out as a carbon ion. So you get CX3, you get CX3 with a negative charge, and plus you get C, double bond O and OH. So this is what happened. Now we are up to the last segment here. You need to pay attention. Now what happened? How the chloroform or bromoform iodoform is forming. Now, like I said, this hydrogen, pay attention here. This hydrogen, and there is a competition here between sodium. So it is positive charge. So when this bond breaks, this sodium replaces the hydrogen, and this hydrogen, comes out here. And this way you are able to form your CHX3, your haloform. That was the final product. This is your haloform. And another product, that was the salt RC double bond O, ONA. Right? This was a sodium, carboxylic acid salt of sodium. Let me write the name. Carboxylic acid salt. Carboxylic acid salt of sodium. Salt of sodium. So this is how the reaction actually takes place, and this haloform is formed. Now I hope this was really very important and you went in in a single step. In case there was a problem you might have, then let me repeat back everything here. What happened in the mechanism? This compound where you have a methyl group on the alpha carbon is here. This is your alpha carbon. This is your alpha carbon here. So this is your alpha hydrogen, right? I've already mentioned that. So alpha hydrogen is highly acidic, so it reacts with the OH produced by the NaOH and it forms a water. And then what happened? This forms a carbon ion. That carbon ion is here. In the next step, what happened? This carbon ion develops a dipole moment, and this is called dipole induced dipole. Dipole induced dipole. I hope you do know. So initially it was a non-polar, but because this halogen molecule is in contact with the negatively charged particle, so this develops a dipole-induced dipole, and because of that the halogen moved towards the carbon and formed the first substituted compound. After this first halogen has come over the place of the hydrogen, it required 2 mole of NaOH. We could have done it in a bit bigger way, but I have done in the same step 2 NaOH and 2 X2 will result replacement of both of the hydrogen. Remember, both of this hydrogen I have replaced by the same step, and this forms actually RCOC again AX3. So this is what the thing is. Now what happened? Again, since the solution, if you remember, I told you there were 4 mole of NaOH required. So this 4th mole of NaOH, produce OH, and this OH, comes with the electrophilic carbon and it attaches to the electrophilic carbon while this bond undergo cleavage. So this form a negatively charged CH3 you have right here, and this form a carboxylic acid. So this is a carboxylic acid. After that, what happened? The sodium and hydrogen, they undergo competitive substitution, right? They undergo competitive substitution. So sodium react with oxygen and hydrogen react with the carbon, and this way it finally forms the haloform, and this become a carboxylic acid salt of sodium. So this was the mechanism. Actually, I tried to make you go right. There are more about this topic, but now let's try to understand if there is any other compound which can also exhibit this haloform test positively, right? There are actually. So that's why let me remove this off, and then I'll take you. You remember a secondary alcohol, and with that you also need to remember the oxidation of secondary alcohol. So I'm talking about 2-degree alcohol. 2-degree alcohol with methyl group. With methyl group. Methyl group, right? So if there is an alcohol which is of 2 degree and has a methyl group on one of the side, maybe on both sides, but maybe on one side, then this can also exhibit haloform test positive. So let's see that. Let me put this something like this. This is your secondary alcohol and this is your methyl, right? So this is your 2-degree alcohol. This is a 2-degree alcohol. Now if you remember, this one undergo oxidation. It undergo oxidation. Now as it undergo oxidation, what happened? Both of these hydrogens are pulled up by the oxygen. They are being pulled up by the oxygen, and it results formation of H2O. And along with that, what happened? A double bond is restored between the carbon and oxygen. A double bond is restored between the carbon and oxygen. Now, this is a methyl ketone you have. This is what you have, a methyl ketone. Methyl ketone. So if you have a methyl ketone, then it can undergo, right? So let me write this statement and then I will do the mechanism part. Since 2-degree alcohol with methyl group on oxidation produce ketone, and therefore 2-degree alcohol can give positive result with haloform reaction. Can give positive result, can give haloform test positive. Haloform test positive. So this is your statement one. Now let's talk about what happened here, right? So for that, you have to concentrate here. Now what happened in the next step? This react with the same mechanism where it react with 1 mole of NaOH and 1 mole of halogen, right? So what will happen? This will form, let me put the same thing here. Let's this suppose 4 mole and this is your 3 mole. So this will directly produce RC double bond O, ONA, and apart from that it also form CHX3. So this is how a secondary alcohol can also undergo haloform reaction. So this was also very important to understand that is there any other compound which exhibit iodoform test positive, then the answer is yes. And what that compound is? A secondary alcohol which can undergo first and convert into a ketone. After it convert into a ketone, then the ketone can be converted into a haloform, right? So, but I would like to add something here. I'm repeating ketone, ketone, ketone. Not every ketone. You have to understand that a ketone with a methyl group can only undergo haloform reaction. You need to understand that only a ketone with methyl group, not ethyl, not propyl, any other. It's only methyl group, right? So with that, I have completed the whole topic here. The entire, that was really, hazy. But I must say thanks for being here. And in case you have liked, do give me your feedback how this good or bad was. Though I wanted to make it in Hindi, but I did it, in English. I'll try to make this, also in Hindi someday, right? Thanks for watching.